All right, now we're going to do section 1.2. Now, section 1.2 is talking about functions. Again, something else that you talked a lot about in Algebra 2. It's a function if each element of the domain is the x value, that's called the independent variable. If each element of the domain is matched up with exactly one member of the range is y, the dependent variable. So every x is matched up with exactly one y. So you could have the point 2, 3, but you couldn't have a point 2, 4, because there x is 2, it's matched up with two different y's. This probably doesn't make, this is a bad analogy on my part. I always think it's like in your calculator. If you took 3 times 4 and got 12, would you want to take 3 times 4 and get 17? So if you plug in one thing, you want to get the same answer every time. So that's a function. So as long as the x does not repeat, it's a function. One way to test is if it's a function is if it's a graph, you check the vertical line test. So you look and see, can I draw a vertical line anywhere possible? If you can draw a vertical line anywhere possible, if it ever goes through two different points, if it touches in two different points, it's not. So here, these are some determinants of function, like this one here. If I gave you this set of ordered pairs, 1, 2, 2, 4, 3, 2, 4, 5, is that a function? Well, look at the x's. 1, 2, 3, 4. None of them repeat, so this is a function. It says list the domain and range. Well, the domain is all the x's. So that'd be 1, 2, 3, 4. And you might be tempted to put 1 through 4. Well, that isn't. It's only those 4. That's all we know about, just those 4. The range is the y's. So here the y's are 2, 4, 2, 5. Now notice 2 occurs twice. That's okay. It's still a function. It's all right if the y repeats, just not the x. So the range is 2, 4, 5. We don't need to list the 2 twice. Okay? This one here. Is this a function? Well, look at the x's. -1, 0, 2, -1. Oh, there's 2 negative 1s. This one is paired with 3. This one is paired with 4. So this is not a function. Because -1 is paired with 3 and 4. So it's not a function. Now, I mentioned before, if it's graph, that's an easy way to tell if it's a function. Vertical line test. So if we look at this graph, if I drew a vertical line anywhere possible, does it ever cross that graph in more than one point? No. So this one is a function. Now for the domain and range, I don't know if you've done this very much, but it's pretty easy. Remember, the domain is the x coordinates. So it's x goes left and right. So you look at it, how far left does it go? Well, it goes over to -4. So I'm going to use interval notation. So -4, now it includes -4. Remember, if it includes it, we put a bracket. On the right, it just keeps going to the right. So on the right, it's going to infinity. So that's our domain. So for a domain, you just look and say, okay, how far left does it go? How far right does it go? As long as there's no breaks. Now for the range, well, range is our y coordinate. That's up and down. So we look and say, okay, how far down does it go? Well, it looks like it goes down to -2. Looks like the low point. So let's put -2. How far up does it go? Well, it goes up to a +3. So that would be the range. So how far down to how far up? This one here, is this a function? Well, if I drew a vertical line, notice like if I drew one right here, doesn't it touch in more than one point? So it fails the vertical line test. So this one's not a function. So that's the two easiest ways to tell function or not. If you get ordered pairs, look and see if the x repeats. If you have graphs, check the vertical line test. The hardest way is when they just give you an equation. You have to kind of think about it. So like here, if I plug in a value for x, will I ever get the same thing for y? well, you could try a bunch of points or you could graph this. I'll just tell you, no, you don't ever get the same thing. So this is a function. Now for the domain, we look for two different things. You look if it has a denominator, or you look and see if it has a even root, like a square root. Those are the two things you look for on domain. If it's not one of those two things, then it's all real numbers. Here it has a denominator. Well, for the domain, what you do is say, well, we know the denominator of a fraction can never be 0. So we say that x minus 2 cannot be 0. And then we solve that. So if we add 2 to both sides, so that means x cannot be equal to 2. That's our domain. And it's usually okay to just write it like that. X cannot be 2. Sometimes if you have to put it in interval notation, you could say, well, it could be left of 2. So that's from infinity to just short of 2. And it could be right of 2. So it could be 2 to infinity. So if they ask for an interval notation, because that means everything except 2. Now the range, here you have to just think about, could this graph just keep going up? Could it keep going down? Probably the easiest way to do that would be to graph it. If you graph that on your calculator, that'd probably be the easiest way to tell. If you graph it, the graph looks something like this. So you can see it keeps going down, it keeps going up. So we'll just leave the range blank for that one. This one here, is that a function? Well, let's solve that for y. So if I get y by itself, and now I divide by a negative, now we square root both sides. Well, remember, whenever you square root both sides, we put a plus or minus. So that's important, that plus or minus, because that means if I plug a number in for x, like let's say I plugged in 2. 2 squared is 4, minus 3 is 1. Well, the square root of 1 could be a positive 1 or a negative 1. So that means if I plug in 2, I get the point 2,1. I also get the point 2, negative 1. Well, notice 2 is paired up with two different numbers, so that's not a function. So if you solve for y and you get a plus or minus, it's not a function. Now here, this one, notice we didn't square root both sides. The square root's already there. So this is a function. Square root functions usually look something like this, kind of half of a sideways parabola. So this one is a function. Now I mentioned before for domain, there's two things you look at. Well, one is a denominator like we had on the first one. The other thing I said was a square root, because we can't take the square root of a negative number. So for our domain, whenever you see a square root, you say, okay, whatever's underneath the radical cannot be negative. Well, cannot be negative means the same as greater than or equal to 0. So we start with that. X minus 1 is greater than or equal to 0. Well, if I solve for x, I get x is greater than or equal to 1. That's our domain. For the range, here, if we take the square root of this, our answer can never be negative. So here, that's our range. If it can never be negative, it never goes below the x-axis. So our range is y is greater than or equal to 0. Or again, this could be 0 to infinity. This could be 1 to infinity if you did it in interval form. So that's how you tell if it's a function or not. That's 3 ways to tell. All right, the next thing is evaluating a function. The key thing to remember here is this is function notation. H of t, for the letters they'll use f or g or h. H of t, there's our function right there. Whatever's in the parentheses is what we plug in for the variable. So here, h of 1, that tells us to put 1 in for t. So it's 1 squared minus 2 times 1. That's 1 minus 2, which is negative 1. Or h of negative 3, we put negative 3 in. So we're going to take a negative 3 minus 2 times negative 3. Negative 3 squared is 9. Negative 2 times the negative 3 is plus 6. 9 plus 6 is 15, so h of negative 3 is 15. Here it's h of a. So again, we plug a in for the variable. So it'd be a squared minus 2 times a. The one that always gives us trouble is this x plus 1. Again, it's the same thing. Whatever's in parentheses, we put in for the variable. So we're going to put x plus 1 in for that t. So we're going to have x plus 1 squared minus 2 times x plus 1. If we squared this out, it'd be x squared plus 2x plus 1. If we distribute the negative 2, that'd be negative 2x minus 2. If we combine like terms, we have an x squared. 2x and a negative 2x cancels out. 1 plus a negative 2 is a negative 1. So even though it looks like this, whatever's in the parentheses is always what you plug in for x. All right. This next one, this is called a piecewise function. I don't think you've seen these very much. It's called that because it's in pieces. This one is actually in 3 pieces. Out here you'll have the domain. So when x is less than 0, you use this function. When x is between 0 and 1, you use this one. When x is greater than or equal to 1, you use this one. So it's in 3 pieces. So when you're asked to find one like f of negative 2, we first find the appropriate domain. Well, negative 2 is less than 0, so we're going to use the top one. So negative 2 plus 2 is 0. F of 0, well here x is greater than or equal to 0, so 0 goes in this middle one, that's just 5. So any number between 0 and 1, the value of your function is just 5. Then this one, f of 1, well here this is x is greater than or equal to 1, so we're going to use this one, so we plug in 1, that's 1 squared plus 1 equals 2. That's how you do a piecewise function. You just plug into the appropriate one using the domain. All right? The last thing here, this is something directly from calculus. This is something you do right at the beginning of calculus. There'll be something added to the front of this, but this is called a difference quotient. F of x plus h minus f of x all divided by h. So there's 3 things there. First, we have f of x plus h. Well, just like here when we had h of x plus 1, we plugged x plus 1 in for the variable. Here, we're going to plug x plus h in for the variable. So f of x plus h, we're going to put x plus h in here. So that's going to be x plus h squared minus 4 times x plus h plus 7. So that's that first part right there. We took x plus h and we plugged it in for each one of those x's. Okay? That always gives students trouble. Again, just remember, whatever's in the parentheses is what you plug in for the variable. Now it's minus f of x. Well, f of x is just this function here. So x squared minus 4x plus 7. And then that's all over h. So that's the first part. We have 3 things. F of x plus h, we plugged x plus h in for the variable. F of x, that's just our original function, all over h. Now we have to work that out. Well, here we need to do a lot of algebra stuff. So if we take x plus h and FOIL it out, that's x squared plus 2hx plus h squared. Now we have a negative 4 times all this, so it's a negative 4x minus 4h, and then we have a plus 7. So that's that whole first part. So we FOILed this, we distributed this, we have all that. Now here it's minus all this, so we have to make sure we need to subtract all 3 of those. So we subtract x squared, we subtract a negative 4x, that'd be a positive 4x, and we subtract 7. So make sure we're putting that minus on everything. And that's all over h. Now we combine like terms. So over here, let's see what we have. We have an x squared and a negative x squared. So those 2 cancel out. We have a negative 4x and a positive 4x. Those 2 cancel out. We have a positive 7 and a negative 7. Those 2 cancel out. So we're just left with these 2 things right here and this 3 right here. We have those 3 things left over. So I'm going to write those out. So we have 2hx plus h squared minus 4h, and we still have an h on the bottom. Now, notice all three of these have an h in them. That's always the way it should work. Everything here should have an h. Let's factor out an h. So that'll be 2x plus h minus 4 over h. Well, now we can divide top and bottom by h. We're left with 2x plus h minus 4. That's a difference quotient. Again, you do this at the very beginning of calculus. You'll do this. It seems like a pain in the neck because there's a lot of work to do here, but it always ends up as something pretty simple. Okay? That is 1.2.